Hey, welcome to Blue Pen Land here. Okay, so red elk drops a rock from a 12-meter tall cliff. Okay, so that's right there. Drops implies, I feel like that's, he doesn't throw it, right? It just starts from rest, right? A 12-meter tall cliff, that's a number, right? Oops. What time does it take the rock to hit the water, right? And what is the velocity of impact? So that'd be the final velocity, right? Okay, so that means, by the way, that we must know x, v, I, and a, right? Okay, so here is, here's this cliff. Here's red elk dropping a rock, right? And this must be 12 meters here, right? Right, so I'm going to say that our displacement is that the rock goes down 12 meters. The initial velocity, since he drops it, I'm going to say that that's 0, right? And then the acceleration, we're on Earth. Red elk lives on Earth, right? This is negative 9.8, okay? And now we can figure this out, right? Once we know these three things, right? Now I'll give you a clue. I'm only going to give you three things, okay? So again, he drops it, so the initial velocity is 0. It goes down 12 meters, right? And the acceleration is negative 9.8 meters per second, because that's the acceleration of Earth's gravity. Okay, so now we're all set. Let's see. I think we want to use no t to find VF. So VF squared is VI squared plus 2AX, right? So VF squared is equal to 0 squared plus 2 times negative 9.8, right? Times negative 12. Now notice that we'll end up with a positive number there, right? So 2 times negative 9.8 times negative 12 is 235.2. So VF squared is 235.2. And so therefore the absolute value of VF, right, because we're taking the square root of this, right, is equal to, so I'm going to do second square root second answer. And that's 15.3 meters per second. Now, to be sure, that rock is going down when it strikes the water, right? Okay, so I'm going to put a minus sign. Since the absolute value is 15.3, I definitely know it's going down. So we put a minus on there. Right, so 15.3, this is meters per second squared, right? It's going down, right? That's why we choose negative 15.3 because we know that it's going down, right? All right, and then let's see, what time does it take to hit the water? Let's figure that out, time. We could use, what we could do is use this guy to find the time. Let's do it. We could use x is VIT. Now there's other things we could do to find the time, right? But this is the one that doesn't require me to know the final velocity, so I'm going to use that. I feel like it's better. Okay, so negative 12 equals, and then initial velocity is 0, right? So it's 0 plus 1/2 negative 9.8 t squared, right? Okay, so I can solve this. This thing is 0 because what? The initial velocity is 0, right? So I'm going to go negative 12 times 2, right? That gets rid of the 1/2, divided by negative 9.8. That gets rid of this. And that equals t squared, right? So again, I take the negative 12, type it into your calculator, negative 12, multiply by 2 to get rid of the 1/2, divide by negative 9.8, right? And you get t squared is 2.4489, right? And then I'm going to take the square root of that. So I'm going to go second square root, second answer. And I get 1.5649. Right, almost rounded up, but it didn't. Okay, so it's 1.56 seconds. And then notice that it's negative 15.3 meters per second because it's going to go down, right? It's going down. So you just added that minus sign. That's fine. Because remember, when you take the square root of a square, the answer could be positive or negative. Okay? All right.